Hello everyone, this is the second lesson recording for day 5. So where we left off, we came up with this formula right here. So if I am multiplying one complex number by another complex number in polar form, what I can do is you just take the radius, r is a radius and m is a radius. You just need to multiply the radius and the angle measures for each of the complex numbers, they just need to be added. So for example, let's try to apply that on this problem. If I am multiplying one complex number, 4 cosine of 60 degrees plus I sine of 60 degrees times 7 cosine of 150 degrees plus I sine of 150 degrees, what this means is I just need to multiply the two radius together. So this is same as 4 multiplied by 7. And for the angle measures, cosine is for cosine of the first angle is 60 degrees and the second angle is 150 degrees. So I just need to add those two angles together. And plus I sine of, okay, again 60 degrees is my first angle and 150 degrees is my second angle from the second complex number. Okay, so, and that makes my math a whole lot easier. Okay, so you end up with another complex number, but this time 4 times 7 is 28. And cosine of 60 plus 150 is 210. So cosine of 210 degrees plus I sine of 210 degrees again as well. I don't need that parenthesis right there, so I can remove that. And so this is the final complex number that results when you multiply this complex number with this complex number. And it's in polar form. And this is the beauty of the polar form. The complex numbers in polar form is that when you're multiplying two complex numbers in polar form, you just need, the math is so much easier than the complex number in rectangular form. Okay, let's try another problem. This time, let's use radians. Okay, and maybe you can try this. Pause the video and try for yourself. I want you to multiply 3 cosine of pi over 3 plus I sine of pi over 3. So the first complex number has a radius of 3 and the angle measure of pi over 3. Multiply that by second complex number, cosine of 3 pi over 4 plus I sine of 3 pi over 4. Okay, please pause the video and try for yourself. Okay, so I am going to assume that you've had a chance to try this. Okay, so what do I do? With the radius, I just need to multiply those. 3 times 5 is 15. And with the angles, I need to add those two angles up. So it's going to be cosine of pi over 3 plus 3 pi over 4. I'm going to do my math on the side. Okay, so pi over 3 plus 3 pi over 4, they do not have the same denominator. So what I need to do is I need to convert it to have the same denominator. So that's going to be the lowest common denominator is 12. So what am I multiplying to the first fraction to get 12 as my denominator? I am multiplying to the bottom 4. So I need to multiply to the top by 4. So that becomes 4 pi over 12 is equivalent to the first fraction. And to the second fraction, I need to multiply by 3, so that becomes 9 pi. So I am adding 4 pi plus 9 pi, which is 13 pi over 12. And that is my final angle. So I am just going to use this angle right here. That's going to be 13 pi over 12 plus I sine of 13 pi over 12. And I am done. Simple as that. Now, during the previous video, we derived the product formula for complex numbers in polar form as this. Is there a similar formula for quotient when you're dividing complex number in polar form? And yes, there is. And here it is. So if I am dividing two complex numbers in polar form, so this is a first complex number divided by a second complex number. This time, instead of multiplying the two radius, this time we are dividing, okay? And instead of adding the two angles, you are going to be subtracting the angles. So it is just, you can understand where it comes from. The R and M gets divided, and instead of the angles being added, you are being subtracted by. And let's try to use this by doing a problem. So example, if I have a complex number like 10, radius of 10, cosine of 180 degrees, plus I sine of 180 degrees, divided by 20, cosine of, say, 45 degrees, plus I sine of 45 degrees. Okay, so the numerator is a complex number and the denominator is also a complex number. What I need to do with the radius is I just need to divide. Okay, so that is same as 10 divided by 20, and with the, it's going to be cosine of, this time because we are dividing, we're subtracting the angle, so that's going to be 180 minus 45. So 180 minus 45 is going to be 135 degrees, and plus I sine of 135 degrees. And that makes my math very, very easy. So now you might have noticed that when you are writing polar form of complex numbers, you are always going to have cosine of the same angle and I sine of the same angle. Is there an easier way? Oh, by the way, I should have simplified this to 1/2. So let me just do that right now. This is going to be half 1/2. Okay, is there a easier way to communicate the same thing? You see, mathematicians are efficient, or another way of saying that is we're a little bit lazy. If there is a more efficient way to communicate the same thing, we're going to find that. And we have come up with a shortened polar form notation, okay? Because we are always dealing with the same angle. So what we have said is, if you're trying to write this is a complex number in polar form. Okay, we can rewrite this and say we have the variable r here, and c cosine and I comes from this I, and then sine comes from here, and then some angle theta right there. Okay, so this is just a shorthand version of the same thing. So r cosine of theta plus I sine of theta, it can be rewritten as r cis theta, and that is much quicker to write and easier to process. Okay, but this is optional. You do not have to use this if this is confusing you more. Okay, all right, so let's try another problem. Okay, so another example. This time we're going to try to prove that all these formulas work, right? So what you're going to do is find the product, then repeat the process by multiplying the polar form of each pair of complex numbers using the product formula. So first thing I'm going to do is, this is two complex numbers written in rectangular form. So I am just going to multiply that out using the rectangular form. So when I do that, I am doing the same thing. Distribute using FOIL. That's going to be 4 times 3 is 12. 4 times negative I is negative 4i. I times 3 is positive 3i. Positive I times negative I is negative I squared. And from here, I can say that 12 minus 1 becomes 12 plus 1. And then we have negative 4i plus 3i. They are like terms too, so that becomes, they combine to negative I. So 12 plus 1 is 13 minus I. So this is multiplying in rectangular form. And we are going to try to convert each of the complex numbers into polar form and use the product formula. So the problem is this. So the first thing we need to do is we need to change each of the complex numbers into polar form. So let's start with 4 plus I. The first thing I'm going to do is I'm just going to do a quick sketch. 4 plus I on the polar plane, the real number is 4. So let's just call this 4 here. And positive 1 will be I right there. So it's going to be in quadrant 1. Okay. So then from here, I am saying I need to figure out what radius is and what the angle measure is. So radius is going to be square root of a squared plus b squared. A in this case is 4 squared, plus b in this case is, there's 1 right there, right? 1 squared. So that becomes 4 squared is 16 plus 1 is going to be 17, square root of 17. Okay, so r is square root of 17. Then what about angle measure? Angle measure, remember the tangent of theta is going to be, here we have 4 plus I here. So tangent of theta right there is going to be opposite over adjacent. And opposite is going to be the vertical number, which is b. So tangent of theta is always b over a. That means that theta is going to be inverse tangent of b over a. And what is b? b is positive 1 and a is positive 4. So it's going to be 1/4. And if I use the calculator, I get 14.036 degrees approximately. Okay, so it's a very small angle. Okay, and since it's in quadrant 1, this will be a correct angle measure. Okay, let's do the same thing for 3 minus I. 3 minus I, what is the radius? Radius, remember, is square root of a squared plus b squared. And in this case, a squared, a is 3, so that's going to be 3 squared, plus b is negative 1 here, right? So that's negative 1 whole squared, and that is 9 plus 1, which is 10. So r is going to be equal to square root of 10. And what is theta? Theta is going to be inverse tangent of b over a. And b is negative 1. Okay, negative 1 over a is 3. So inverse tangent of negative 1 over 3. And the calculator is going to give me negative 18.435 degrees. Okay, but if I plotted this, and I should have done so before I started, 3 minus 1, positive 3 minus 1 is actually down here. Okay, so this is 3 minus 1, I, and again, this is my real axis, and this is my imaginary axis. Okay, so now that means that 3 minus I can be written as 3 minus I can be written as r is square root of 10. And let's use the shortened version. So we can write, instead of writing cosine of negative 18.435 degrees, I can just write cis negative 18.435 degrees. And I can do likewise for 4 plus I. So I have 4 plus I is equal to, radius is square root of 17 times cis. The angle measure is 14.036 degrees. Okay, so then we just need to use the product formula to find the final answer. So putting it together, multiplying these two complex number is equivalent to multiplying this complex number in polar form multiplied by this complex number in polar form. That means we just need to multiply the radius and add the two angles, and you end up with this.